And on the business of the day, today we are going to use another data set, the one that I shared with you. The data was on lung capacity. Lung cap data is a text. So let us take our data today. Let us call it DF1 because you have another DF on the other side. And we are going to load it using another way. So read delim. And then to avoid so many issues, just say file dot choose, and then run that. When you run that, it brings you this dialog box whereby you can choose that data, which is lung cap data. Lung cap data is a text, okay? And let us view it. View the DF1. Let's see how it looks like. So we have lung capacity. These are data of smokers and lung capacity, their age. So the lung capacity of an individual, the age of that individual, the height of that person, whether that person smokes or not, no or yes. This is called a logical data structure, a no or yes. The gender is either male or female. This is a categorical data as well. Cesarean, whether this person was born using the cesarean method of the operation, so no or yes. So that is a description of the data. Lung capacity, the capacity of the lungs, the volume of air that a lung can hold. So you can determine whether between people who smoke and those who do not smoke, which have a larger lung capacity, and whether smoking affects the lung capacity of an individual, and whether lung capacity increases or decreases with age, whether lung capacity is affected by age, by height, whether is affected by gender. Maybe males have a larger capacity than females, and such kind of information. Now, I want us to take age here, and I want us to play with this age. I want us to do a t-test for this age, a one sample t-test. Okay, so let's go back here. But first, I want to take the people who smoke, the people that smoke. So smoke, we say yes. Okay, so let's take our DF, let's just call it DF2, and say, let's want to take our DF1, and then what do you want to do? You want to filter under smoke is equals to the people that smoke, and that is yes. Let's see, DF2. So yes. So let's go back here. Let us attach our DF2. Let's attach it for easier use. So as you can see, this is a data set of people that smoke. They may be male or female, but the smoking category is yes, people who smoke. What I want us to do is to estimate the age at which people start smoking. So this is hypothesis testing. So let us start at that. Let's say our null hypothesis. Let's say that smoking age is greater than, let's say, 15, greater than 15. Therefore, the alternate hypothesis will be alternate hypothesis will be smokers are less than 15 years. 15 years. Smoking is greater than. So smokers here. So we want to check whether smokers are greater than 50. So our null hypothesis is that smokers are greater than 15 years of age, or smokers are less than 15 years of age. So let's do a t-test. So just put t.test is a one sample t-test, and you are putting the age. Age. So another thing you would like to do is the alternative hypothesis. So alternative hypothesis will be, so because the null hypothesis is that smoking is greater than 15, so the smoking should be less. The alternative hypothesis is less. And you can put the confidence interval, the confidence that you want. Let's put it at 95%. And let's run that and see what happens. In a sample, in t-test, in a parametric test, this t-test, we are doing a test for the means. What we are doing is we are comparing the mean, but this one is a one sample t-test. So we want to make an assumption of the mean of the age of a smoker. So what I left out is the function for mean, which is we said 15. Mu is mean. So smokers are greater than the mean of 15. On average, we want to say that if you take a group of smokers, the average age of a smoker is 15 or more. And therefore, the smokers are age is less than 15 years of age. Therefore, the alternative hypothesis here was supposed to be less because the null hypothesis is that the mean age of a smoker is greater than 15. Therefore, the mean age of a smoker is less than 15. So let's see whether that works. Exactly. Now, when you come here, one sample t-test, data is the age, your t statistic is 0.7, but the p-value is 0.23. So this is greater than 0.05. What does that tell you? That the smoker's age, mean age is greater than 15 years of age, 15. The mean is greater than 15. Let's put the mu is equals to 15. Okay. Let's say the alternative, let's say this was greater. What would happen? Let's see. This is 0. There has to be a mistake here. Alternative true mean is greater than 15. 95%. There's something I did not show you earlier. If you ever got stuck, like I'm getting stuck today here with this simple test, you can search what to do on this RStudio. So you just put a question mark before the function. So question mark t.test. Then you enter that. Then it gives you a summary of what you're supposed to do here. So it's a student t-test. So x, y null, alternative, two-dot-sided, less or greater, mu is equals to 0, paired is equals to false. Okay, these things are for two sample t-test. Okay, it is business. But if you check, let us check a person of 10 years. So we assume that the null hypothesis that the smoker's age is greater than 10. Let's see. It is 1. So yes, that person has to be greater than 10. That is true. The mean age is greater than 10. So let's see about 13. Put 13 here. That person, the mean age of a smoker is greater than 13. Let's see. Yes, it is greater than 13. Is that person greater than 14? Let's see, greater than 14. Yes, that person is greater than 14. Is that person greater than 15? Let's see. Oh, sorry, this is not supposed to be there. Yes, that person has to be greater than 15. Greater than 16? No. So that person has to be 15 point something of age. So if that's what you do at t-test. This you do when you're sure of a mean. Maybe you know the mean age of people who smoke. For example, I guess in Kenya you can start smoking as long as you are 18 years old. So the age of smoking might be 18 years and above. But for this taken in another area, it shows that people who smoke are less than 16 years of age, less than 16 years of age. Because when you say that the mean value of the smoker is greater than 16 years of age, it tells you no, is less than 16 years of age, but more than 50. So it's about 15 point something. Yeah, that's how you do a t-test. I hope have not confused you too much, but it's in rare cases where you do a one sample t-test, but that as one sample t-test. You have an assumed mean. You want to assume, due to your prior knowledge, the age of smokers in this country or in this region is these years. So you assume it is that. So you start with an assumption that the age of smokers in my area of study is 15 years. Then you use one sample t-test to add to ascertain your hypothesis. And in this case, we have seen that the age of smokers is less than 16, but it is more than 15. So it's about 15 point something around there. Yeah, so that is it. That is all I wanted us to do today. I hope it has made sense to you. Yeah, that is it. Any questions, any clarification, something I can repeat so that you may understand it well? And as I said of looking for help, you can look help for anything. So you can just put a question mark before anything and write what you want to write. Maybe you want to ANOVA. Then what it does, it gives you everything that it is fit an analysis of variance model. So that is everything we did last time. And then you can also use help and say, I want to know about LM, that is linear models, enter. Then it gives you, it does the same fitting linear model. So you can use a question mark or help, or you can come at this under help and search whatever you want to do. Maybe you want to search JLM, generalized linear models. Yeah. Any questions up to that point? This one sample data is not as important, but it's good that you just understand it. Then next week, you're going to do a two sample t-test whereby you compare two different things. And then we did for 3 means, that is ANOVA 3 and more means, that was ANOVA we did last time. And then we can do one final test of called the chi-square, the chi-square test. Then we can be done with the statistics for now. And when we go back to our visualization, we do some visualizations. I think that is it for today. And you want us to use greater. So if you say this is greater,
yes,
then meaning that your null hypothesis was that it is less than. For your alternate to be greater, then your null hypothesis has to be, if your alternate hypothesis is greater than that age, greater. So meaning that your null hypothesis, which you always test, this is what we are testing, this is what we test against the p-value of 0.05, then this has to be less, this has to be greater. Let us run this, see what happens. To give us a p-value of 0.9. So this is greater. This is greater than 0.05. Therefore, we fail to reject. So we say that the smokers are less than 16 years of age, and that is true because they are not more, they are not greater. That's what we have just said, that the smokers are less than 16 years old, but greater than 15 years of age.